Today we'll be focusing on parallelograms and their properties. So the first thing to know about parallelograms is, well, what is a parallelogram? Parallelogram is, in simplest terms, a parallel quadrilateral in which the opposite sides are parallel to each other. Some parallelograms are squares or rectangles and rhombuses. Those examples I just told you are special parallelograms. And the special parallelogram is a parallelogram that has other properties that aren't true about all parallelograms. But this lesson focuses primarily on properties of all parallelograms. Next lesson is special parallelograms. So right here, I have a GeoGebra open. This is to help us write out all of these things over here. All of the answers. So let's get started. In a parallelogram, the opposite angles are... So we need to find the opposite angles of this parallelogram. So let's see. These two opposite angles are congruent, if you didn't see. It just gets weirder and weirder. So these are both congruent, obviously. Are these congruent? Yes. So if we move around this quadrilateral, well, really this parallelogram, the opposite angles are always congruent. So for every parallelogram that exists, the opposite angles are always, are always congruent. Now the opposite sides are parallel. We know that by the definition, but the opposite sides are also, let's see, remember the sides. Remember that from last lesson. We really shouldn't have to explain sides because triangle sides, everything. But right now, it seems that they're congruent. But to make sure this isn't something that only a special parallelogram has, we're going to move this around. So these side lengths are always staying congruent because in a parallelogram, the opposite sides are parallel and congruent. And then the consecutive, this is supposed to say angles, by the way, that's my fault. Consecutive angles are, well, let's look here. This is 108 and 72. Those are supplementary. If I move this, it's a little hard, but the angles are always going to be supplementary. And if you are a little confused, think of it as the parallel line theorems. These are consecutive interior angles, and it's really helpful to look at it with the sides, the sides stretched out. So consecutive angles are always supplements. Are supplementary. So I'll write supplementary for short. And then the diagonals. Remember, a diagonal is a segment that connects two sides. There's a segment here, and there's a segment here. So first we're going to see, well, are the segments themselves congruent? Are the diagonals themselves congruent? And that is no. My fault. No, they are not congruent. So what is special about this? What if we measure out each individual segment and see what's true about that? I'm going to move this around to make it cooler. Wow. So these aren't obviously congruent, but these two smaller parts of the segments are congruent. No matter how we change these segments, the smaller parts are congruent. So what that means, they bisect each other. So here are our new parallelogram theorems. And we just saw using GeoGebra that these theorems are true. So the parallelogram opposite angles theorem states, if a quadrilateral is a parallelogram, then the opposite angles are congruent. No matter what the parallelogram is, it can be a special parallelogram, it can be the most weirdest parallelogram, the opposite angles will always be congruent. And the same holds for the opposite sides. If parallelogram opposite sides, theorem, quadrilateral, parallelogram, blah, blah, blah. Then the consecutive angles in a parallelogram are supplementary, as we saw. And then the parallelogram diagonal theorem just states quadrilateral is a parallelogram, then the diagonals bisect each other. So those are the 4 parallelogram theorems. And for any parallelogram, for any quadrilateral in which the opposite sides are parallel, these will hold true. However, that doesn't mean all parallelograms will have 90-degree angles. For every parallelogram with a 90-degree angle is going to be a rectangle. That's special about a rectangle. And a rhombus have all sides congruent. The square is a rectangle and a rhombus, and we'll explore that more next lesson as we understand the properties of these different types of parallelograms. Now we have a nice, easy challenge problem. So now I'll just move this out of the way so we can do this. So it says this is a parallelogram. So these opposite sides are congruent, and the opposite angles are congruent too. So x plus 4y equals 64. We are given 3x plus 4y equals 126. And this is just simple. Cancel out. And I'll get a calculator. So 64 minus 126 is negative 62. So x equals 31. And because x equals 31, let's see. 31 plus 4y equals, what is that? 64. 4y equals, 64 minus 31 is y equals 33 over 4. So those are our 2 solutions. Those are the values of the 2 variables. And how we use our different properties of parallelogram to find these, that allowed us to solve them. So that is parallelograms explained. Recap, we learned the definition of parallelogram: opposite sides parallel, opposite angles are congruent, opposite sides are parallel and congruent, consecutive angles are supplementary, and the diagonals bisect each other. And we learned so many new theorems, and we learned a challenge problem. So, I'm sorry, next lesson isn't special parallelograms. Next lesson is proving a quadrilateral with a parallelogram. We'll be looking at how to identify a parallelogram in a coordinate plane, and we'll be learning the converses of all these theorems in a new theorem which helps us prove that a quadrilateral is a parallelogram. So I hope you understood all that, and I hope you make sure to be the most proficient as you can with this.